right, 7th grade, we're going to start working on the third section of this unit, which covers polygons. And the important parts of polygons are that they only have straight lines and they have to have closed sides. So for a polygon, a figure like this would be a polygon because it only has straight lines or sides and the sides are all closed. Something like this would not be a polygon because the third side is not closed. So for a regular polygon, it is a regular polygon if all sides and angles are equal. So in an example of a triangle, this would be an equilateral or a regular triangle, whereas this would not be because the sides are not all equal to each other. Okay, so let's start looking at some examples here. So the question becomes, are the shapes that are shown polygons? So for example, this one here, yes, is a polygon because it's closed and all the sides are equal to each other. The sign up here at the top, yes, would also be a polygon. All the sides are closed and they're all straight lines. The pentagon would be a polygon as well. But this one here is not a polygon because the sides are curved here on the end. And this one here, this is a little tricky, but this is also not a polygon because the sides cross each other. But if you split it up, this would be two separate polygons or triangles. So this table right here is worth candy if you're able to get this table filled out and show it to me in class. What this is the sum of all of the angles, and sum means add. So what all of the angles on this problem would add up to in this equation. So a triangle by definition has 3 sides, but the angles would add up to 180 degrees. A quadrilateral by definition has 4 sides and has 360 degrees. And if you scroll all the way down, we call these n-gons, which means if you take the number of sides and you subtract it by 2 and multiply times 180, you'll get the total. So an octagon, if I do 6 times 180, because it has 8 sides, 8 minus 2 is 6, that would give us the number. So a nonagon would have 9 sides, and I would do 7 times 180, which would be equal to 1260 degrees. And a decagon has 10 sides, so that would be 8 times 180, which is 1440 degrees total. Once again, that's worth candy if that table is fully filled out. So for each of these shapes, I want to define what the shape is and then what the total number or what the total sum of the interior angles would be. This one here has 4 sides, so we call this a quadrilateral. Now, also important, these have to be spelled correctly on quizzes and tests or they will be counted wrong. A quadrilateral, we take 4 minus 2, which is 2. And 2 times 180 is 360 degrees for the sum of interior angles. All the angles add up to 360. This here, by definition, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So this is a decagon. And a decagon has 1,440 degrees for the sum. This one is 1, 2, 3, 4, 5, 6, 7. 7 is a heptagon. And so that would be 5 times 180, or our table says 900 degrees. And this last one here looks to be an octagon, nope, hexagon, sorry, 6 sides. And so that would be, whoops, 720 degrees. Let me spell that a little better here. There you go, hexagon. So, now what this tells us is what type of shape it is, and then if all of the angles are equal to each other. So this right here is a triangle. A triangle adds up to 180 degrees interior angles. Therefore, since there are 3 angles and those angles add up to 180 degrees, I take 180 and I divide by 3. So this is 6. 60 degrees for each angle. This, by definition, is a quadrilateral, which adds up to 360 degrees. So each of the angles has to be 90 degrees. And the last one is an octagon, so that's 540 degrees. And so this one, we'll get a calculator out. So I go 540 divided by 6. Whoop, I made a mistake here. This should be 720. Sorry about that. 720 divided by 6 would be 120 degrees for each x value. I have hiccups. All right. I would like you to try these on your own to tell you what each of the values would be for these two shapes. So for this one over here, since I know this equals 360 degrees, I know that 110 plus 110 is 220. And then plus 2x's is going to be equal to 360 degrees. Well, we learned how to do this a while ago. So I'm just going to subtract 220 from both sides. So I get 2x is equal to 140 degrees. Therefore, each x is equal to 70 degrees. Now, if you didn't write it out as this type of linear equation, that's fine, as long as you got x equals 70 degrees for each of these shapes. And this one over here is a heptagon, and that means 540 degrees total. So each one of these is 108 degrees. And as always, if you have questions, make sure you ask them in class tomorrow.